Hello. In question 6, we're going to be doing some chain rule practice. We're going to have a few functions, and we're going to have to find the derivation of all of them. Some of these functions may have known derivatives, but I would suggest practicing chain rule on these because that is the point of this problem. For part 1, we're given ReLU of W transpose x1. Now, reminder of the chain rule, we need to find the derivative of the outside and then the derivative of the inside. And we take the product of those two. Now, ReLU, the derivative of ReLU, is actually fairly simple. The graph of ReLU looks like this on the left. So we can see that when x is greater than 0, ReLU returns x. And this means that the derivative of ReLU in this segment is 1. Additionally, when we look at when x is less than 0, ReLU returns 0. And the derivative of that is 0. So what we need to do here is we need to calculate out ReLU of W transpose x1. And this is W transpose of x1. So that would be 1, 0 times, or dot 1, 1. That is 1. So that's ReLU U. ReLU of 1. And that is 1. So we know that this is roughly around here. So the slope, or the derivative, is 1. Now we multiply that by the derivative of the inside, so W transpose x1, and ddw, I just do ddx by instinct, but it's actually ddw here. ddw of W transpose x1 is equivalent to x1, which in this case is 1, 1. And so our full equation is going to be 1 times x1, which just equals 1, 1. So our answer is just 1, 1. All right, for part 2, we have a summation. This is chain rule practice, but we also need to remember that when we take the derivative and there's a sigma notation in there, we can just ignore it. So for part 2, we're going to do 1/2, keep the sigma notation in there, and we're going to take the derivative of the outside. So we're going to do 2 times of W transpose x sub I minus y sub I. And then we need to take the derivative of the inside. So in this case, it's going to be, derivative of W transpose x sub I is just x sub I. And the derivative of y sub I is 0. So we can get rid of that term. And this is what we have. So now we can cross out the 2's here. And we are left with this. And we can put this out into long form because the sigma notation only has 2 elements, so it's only the sum of 2 elements. So we've got, my W's are so bad today, W transpose x1 minus y1 times x1, and that is summed with W transpose x2 minus y2 x2. This is 1, 0 times 1, 1 minus, I believe this is 2. Y sub 1 is 2, and x2 is 1. It's negative 1. So now we have 1, 0, negative 1, 0, minus 0. Oh, these all need to be multiplied by 1, 1, negative 1, 0. Okay, so we do this out. You get 1 minus 2 times 1, 1 plus, this will get us negative 1 minus 0 times negative 1, 0. So we get plus 1, 0, negative 1, negative 1. And that gives us our answer, 0, negative 1. That's our answer to part 2. For part 3, how much more space do I have? Okay, plenty. For part 3, we see this. This is the logistic function. This has a known derivative, but we're going to chain rule it out anyways because this is great practice. All right, so we can rewrite this as 1 plus e to the negative w transpose x1. When we do that, raise it to the negative 1. Now let's use the chain rule here. So we do negative 1 times 1 plus e negative w transpose x1 minus 2 times dw of 1 plus e to the negative w transpose x1. And that is just times, I believe the derivative of this is e to the negative w transpose x1. But we have to multiply this, again, by the chain rule, because this part, the exponent, needs to be chained. So we do that as well. And so that is negative x1 e to the negative w transpose x1, and again negative 1 plus negative w transpose x1. Okay, so this looks pretty long, but we can solve this. For starters, let me get it in red. We can cross out these two negative signs. Then we can calculate w transpose x1, but we already did that earlier. That is right here. So that's just going to be 1. So we can rewrite this. 1 plus e to the negative 1. Oh, I forgot a negative 2 here. So this is to the negative 2 times e to the negative 1 times x1. So if I put this out, we get e to the negative 1 x1 over 1 plus e to the negative 1 squared. And I believe if we use a calculator here, we could simplify this out further, but on paper at least, if you have a calculator, this is a good enough solution. I think the answer is roughly something around 0.1966. I guess you could technically do this. You could substitute in 1 for x1, just to be more explicit. Okay. That's part 3. Part 4. For part 4, we have the L1 norm returning yet again. So L1, as a reminder, equals the sum of xi to the 1 divided by 1. Or if we just get rid of all the 1s, we get this. So again, we're going to treat this very similar to the ReLU. If we remember what the L1 function does, it is the taxicab geometry distance between 2 points. So when any of your elements increase by 1, then your metric also increases by 1. So our graph is going to look very similar to an absolute value graph. And that's because, well, it is an absolute value graph. So in reality, our derivative is actually just equal to our sine of w. But then we also need to chain rule it. And our interior is just x. Or in this case, w, because w is the input. So that would just be times 1. So again, the derivative of L1, the function itself, is just the sine of the input. So now that we have that, this is just sine of 1, 0, which is what w is, times 1, which just equals 1, 0. And that is our answer for part 4. Very simple.